In this video, I'm gonna talk about the integration. However, it's gonna be integration in one variable first that will gonna make you ready for the topic that we're gonna study next, which is the double integrals. Okay, so it's gonna be the basic formula that you used to have for calculus 1. So you have integral of constant. So this k is constant and it's gonna turn out to be, you have constant k and you're gonna integrate constant, and integrate constant gives you ku plus c. So this one depending on the variable that you are integrating over, so it's gonna be du, so it's gonna be k times u, okay, and plus c. And you have integral of c fu du, so it's going to be c integrate fu du. And you have, this one is called constant multiple, right? So you'll be able to just move the constant, or you just ignore the constant and you're gonna just integrate the function. And you have the sum and the difference between two functions, and you like to integrate. So integrate fx or fu plus or minus du is gonna turn out to be integrate fu du plus or minus integrate gu du, okay? And you're gonna have the power function. You integrate the power function. In this case, it's gonna be integrate u to the n, and this n can be any number except -1. And this guy turned out to be u to the n plus 1 over n plus 1, okay? And you have integral of u to the -1. So this one is going to be just integrate 1 over u. And it's going to be log absolute u. Okay, so this one is the formula that you study in Calc 1, okay? And you have integrate e to the u du, so it's going to be e to the u plus c, and you have integral of exponential function base a. So for here, you see that the difference turn out to be on the base. If you have base e, it's going to be just e to the u plus c. And if you have a to the u, so it's going to be a to the u over log a plus c, okay? And if you have integral of fx dx equal to fx plus c, so you like to compute integral from a to b. This guy is called definite integral. The definite integral is the integral that you have the upper and the lower limit. So you have a and b here, and this guy is going to be called upper limit. And the a here is going to be the lower one. Okay, so if you like to integrate from a to b of fx dx, so it's going to be just the fx plus c. So you have integral of fx dx equal to fx plus c. If you recall, this guy sometimes it's called antiderivative. Okay, or the function that you integrate and you get the function. So it's going to be, you're going to have that capital F function and you're going to plug in the upper limit, subtract by, okay, so you plug in the upper limit, subtract by the capital F, subtract, plugging in the lower limit, okay, and this one is called the definite integral. Okay, so I'm gonna also record the integration by substitution. So the integration by substitution turned out to be the technique that you have used during calculus 1. So when you like to integrate that, it's not gonna be the formula that you have here. So you're gonna let one variable to be u. So like in this case, you would let u to be x plus 2. So you're gonna let u to be x plus 2, and you're going to compute du equal to dx. Okay, so this one is going to be the thing that you normally have done for calculus 1, and this guy will be integrate 1 over u, and dx turn out to be equal to du. So you have dx, and dx turn out to be equal to du, and this one turned out to be u. And this guy will be log absolute u plus c. Okay, and you're gonna have the final answer is gonna be log absolute x plus 2 plus c. So this one is the yellow one. Okay, so this one will be just the integration by substitution. The second one, you see that you are asking to integrate the product between two functions. So you are looking at the second one, which is more complicated. And you see the term that you can make this guy simple by letting u to be equal to x squared. So you would let u equal to x squared. So you get du equal to 2x dx. So this allows you to solve for x dx. So you see that x dx that you see is going to be du over 2. Okay, so this is the thing that you have learned and you have done before. It's called the integration by substitution, and you have du over 2. So in this case, it's going to be integrate e to the u, which is the yellow guy, and you have x dx, which is du over 2. Okay. And you see that this one will be 1/2 integrate e to the u du, and it's going to be 1/2 e to the u plus c, and your final answer will be 1/2 e to the x squared and plus c. So this is how we integrate in calculus 1 before, and this one is going to be the thing that you will need to compute the double integral that we're going to study next. The last one, okay, so you see that you have fraction, and you see the numerator and denominator, and you see that the denominator turned out to be more complicated in this case, and we usually not letting u to be square root the whole thing. So normally we're gonna let u only to be inside square root. So it's gonna be just u equal to x cubed minus 1. So you're gonna let u equal to x cubed minus 1, and you compute du. So it's gonna be 3x squared dx, okay? And you see that you are asking for x squared dx here. So x squared dx turned out to be du over 3. So it's gonna be du over 3. So it's gonna be integral, and you're gonna get 1 over root u, and you have du over 3. Okay, so you're gonna get 1/3, and you have integrate 1 over root u du. So it's gonna be 1/3, and integrate 1 over root u is 2 root u plus c. Okay, so this one will be just 2/3 root x cubed plus 1 plus c. Okay, and this one will be just this final answer. Okay, so it's going to be the final answer, and the final answer turned out to be x cubed square root x cubed plus 1 times 2/3 and plus c. So this is how we find the integral by using the technique called integration by substitution. Okay, so it's going to be the function that turn out to be the product or the quotient, and we don't have the quotient rule or the product rule for integrating. And this one you have learned or you have been studying from calculus 1 already. So we're going to use them in calculus 2 when we like to compute the double integral in this chapter, and we're going to use this guy when we like to solve differential equation in the next chapter. Okay. The next one that I like to talk about turned out to be something very simple. However, it's going to be just the key thing in order to do the double integral. It's going to be integral of constant and integral of constant multiples. So for this one, you learn the formula that when you integrate constant, it's going to be that constant multiply the variable of integration that you are having. So in this case, you have constant, which is 3. So you have 3 is a constant. And you have dx. So you like to integrate. Sometimes we call this guy integrate with respect to x. Okay. And it's going to be the final answer turned out to be just 3x plus c. 3 come from the constant. Okay, so 3 come from the constant. X is just the variable of integration. Okay, so for the second one, you see it's 3. However, this guy is going to be dy. So in this case, it's going to be 3y plus c. Okay, so it's going to be just like that. So this one is going to be just the integral. Okay, and you have integrate k dy, where in this case your k is also constant. So it's going to be just k times y plus c. Okay, so you see the variable y here, okay, that you use here. If I make my constant to be more fancy in this case, so it's going to be e to the k. Okay, so this e to the k is going to be just constant. However, it's more fancy. So this one is going to be constant. Okay, so this one will be e to the k times y plus c. Okay, and this one will be just constant multiple. Okay, so integral of constant is going to be, sorry, not constant multiple, it's going to be just integral of constant. Okay, for the next one, you see it's look abnormal, right? So it's look abnormal because it's x and y on the same integral. However, you have to just like you have to hold on to yourself on the variable a little bit that, okay, this one is dy, so it's going to be the variable y, and you see e to the k here. Sorry, e to the x, it's not e to the k. And e to the x not a function because it's going to be constant. However, the constant in terms of x, it is constant in terms of x. Okay, it can be, okay, it can be for calculus 2. So this one is going to be just e to the x times y. Okay, so like I said, I'd like you to gain some experience when you have to deal with something like this. Okay, so this is the thing that you're gonna have for calculus 2. Okay, it's not difficult. However, it takes some time to like is to get familiar with the thing. So normally it's not going to be e to the x dy. It's so strange. Okay. For the next one, you see it's going to be kx. Okay. So for this guy, you see that it's not constant because you have x here and you have kx here. So this one is going to be substitution. So you're gonna let u to be kx, and you have du equal to k dx. Okay, so you have dx equal to 1 over k du. Okay, so dx will be du over k. du over k, okay? And you're gonna just have 1 over k integrate e to the u, so it's gonna be e to the u plus c. So this guy will be 1 over k e to the kx plus c. Okay, so this one will be just substitution. Okay, so this one you have u equal to kx and you are computing dx. So you are computing dx equal to du over k. Okay, and you're gonna just have the integration by substitution. Okay, so this is gonna be just constant multiple, and sometimes you see that the constant turn out to be in terms of x because you are integrating with respect to y. Okay, the next one you like to integrate to x cubed dx. Okay, so when you have to x cubed dx, so you allow to just see number 2 here. So this one is gonna be 2 integrate x cubed dx, and this guy will be 2. Okay, and you have integrate x cubed dx, so it's gonna be x to the 4th over 4 as usual. So this one is gonna be x to the 4th over 4 plus c, and this one final answer would be 1 over 2 x to the 4th plus c. Okay, so that is going to be constant multiple that allows you to move the constant in front of the integral. The second one you see is going to be also constant multiple, and you see variable pi, constant pi here. So it's going to be pi integrate y cubed dy. And you see that pi will be multiple, and this guy will be pi and integrate y cubed. So it's going to be y to the 4th over 4 plus c. So this is it. This is your final answer. The next one, you like to integrate xy cubed dx. So in this case, you are integrating with respect to x, okay? So the variable that not x turned out to be constant, okay? Variable that not x turned out to be constant. In this case, y cubed is gonna be constant. Okay, so you have to think that it's not x, y is not x. So this one is gonna be y cubed integrate x dx. So you see, sometimes it's hard to get familiar with, or it's not hard to understand. I think you can understand, but you have to distinguish the variable a little bit. It's oppose your feeling in this case. Okay, so in this case you get y cubed integrate x dx, so it's going to be x squared over 2 plus c. Okay, and this one will be your final answer. The next one, you see that it's going to be integrate the same function, but in this case, you are integrating with respect to y. Okay, so you see your constant turn out to be x. Okay, so your constant turn out to be x. And you're going to pull x out, and you're going to just integrate y cubed dy. Okay, and for this guy is going to be x, and integrate y cubed is going to be y to the 4th over 4 plus c, and this one will be your final answer. Okay, so it's going to be x y to the 4th over 4 plus c. Okay, so this is it. So you have to get familiar with something like this. It seems strange, but it's going to be used for double integration. Last one, okay, so integrate e to the x dx, okay. So here it's going to be just same variable x done, so it's going to be e to the x plus c, okay? And you are having integrate e to the y, e to the x dy. So you see that this guy turned out to be constant. So it's gonna be e to the y outside, and you just integrate dy. Okay, and integrate dy turned out to be equal to y. Okay, so this one is gonna be e to the x, and turn out to be e to the x times y plus c. Okay, and for the next one, you are having integrate x plus y squared dx. So this guy will be integrate x dx plus integrate of y squared dx. And integrate x dx, so it's going to be x squared over 2. And integrate y squared, so this guy is just constant. So in this case, it's going to be just y times x, y squared times x plus c. Okay, so it's gonna be just that. The next one is turned out to be opposite variable. So you see that this one is similar to the one on the other side. So you have integrate x dy plus integrate y squared dy, and integrate x dy, so it's going to be constant multiple. Okay, so you have x and integrate y squared dy, so it's going to be y cubed over 3 plus c. Okay, so this one will be just you have to play with the variable. So you see y, and you integrate as usual, y to the third over 3. The next one, you see constant multiple again. So this one, you see the variable that you are integrating turn out to be x. So you have constant. So constant turn out to be e to the 2y. So this guy is constant. So it's gonna be just e to the 2y, and you integrate x squared dx. And so you just have e to the 2y times x cubed over 3 plus c. Okay, and this one is going to be just using the constant multiple. And the next one, the thing that opposite turn out to be, you have y. Okay, so you are having dy. So you're gonna have the x squared turn out to be constant, and you're gonna just have x squared integrate e to the 2y dy, and for integrate e to the 2y, you can just use the formula. We know that integrate e to the kx dx, so it's going to be 1 over k e to the kx. So this guy will be 1 over 2 e to the 2y plus c. And this, we take care x squared as constant. Okay, so it's going to be, we are taking care x squared as a constant. Last two, we have integrate 1 over 2x plus 3y dx, and we have integrate 1 over 2x plus 3y dy. Okay, so for this one, you see the variable that you are integrating turned out to be x in the first case, and it's turned out to be y in the second case. So you have same function, however, the difference turned out to be you are integrating with respect to x in one, and you are integrating with respect to y in another. So in this case, you're gonna just use the substitution u equal to 2x plus 3y, and you're gonna differentiate. Okay, the thing that funny will be you differentiate with respect to x, right? So you have the dx, and it's gonna be 2x plus 3y. Hey, what will be for differentiate with respect to x of 2x plus 3y? So it's gonna be partial derivative. So this one is gonna be partial derivative. So it's gonna be 2 plus 0. Okay, so it's going to be 2 plus 0. So this one is partial derivative. No need to worry anything. So it's going to be just like you differentiate before. When you see that you are differentiate with respect to x, but you see y. Okay, and you get, so you get du equal to 2 dx. Okay, so you have du equal to 2 dx. So you would get dx equal to du over 2. Okay, so this guy will be integrate 1 over u, and you have dx is du over 2. So it's gonna be 1/2 log absolute u plus c. Okay, so it's gonna be just that. So this one is going to be just using the integration by substitution. Okay, so this one will be 1 over u in log absolute u plus c. And we're not done yet, right? So it's going to be 1/2 log absolute 2x plus 3y plus c. So this guy will be just that. Okay. Yeah. The last one. For the last one, you're gonna use again the substitution. So you would let, in this case, u equal to 2x plus 3y. However, you're gonna differentiate u with respect to y because you like to solve for dy. So in this case, you have the dy of 2x plus 3y for me. And you see that it's going to turn out to be 0 plus 3 instead. And so you allow to solve for du equal to 3 dy. So you get dy equal to 1/3 du. And you are having integrate 1 over u, and dy is 1/3 du. So you get 1/3 log absolute u plus c. So you get 1/3 log absolute 2x plus 3y plus c. Okay, so this one will be just the final answer. So this one, okay, so it's going to be u, and it's going to be u, and it's going to be log of 2x plus 3y. Okay, so that is all the thing that I like to lay down some foundation of integral for you in order to deal with the double integral in the next video. Okay, so please, you need to know the formula first, you know some technique like the integration by substitution, and you're gonna have to be able to integrate on this slide, and you need to be able to find the integral on this slide. So when you see dy, it means that you are working with y, so the other variable except y turn out to be constant. Keep that in mind. If you are having dx and you have the other variable except x turn out to be constant, and you can think about that variable as constant multiple, or it's going to be plus constant, or anything that you have concern for partial derivative. Okay, so that you should keep that in mind. Okay, so that's it for this first video.